Hello everyone and welcome. My name is Andreas Filner and I'm one of the co-chairs of the Onyx Special Interest Group for Architecture and Infrastructure. In the next minutes, I will walk you through what our SIG has done over the past year, covering Onyx releases 1.18 through 1.22. Let me start with how we organized ourselves. Christian Bouchot and I are the SIG co-chairs. One of the key things we focused on was making our release process more predictable. We moved to a time-based quarterly cadence. That means every 3 months we cut a release branch on a fixed schedule. Release managers are now appointed earlier with proper onboarding documentation. We also introduced deprecation rules so that whenever we plan to drop a dependency, we announce it to releases in advance. For larger changes, we introduced an RFC process with a structured template. This means that before anyone starts implementing a significant change, the community can review and discuss the proposal first. The table on the slide shows our 5 releases. You can see the release dates, the release managers, thank you all, and our Python wheel coverage expanded with each release. The IR, the immediate representation, is basically the core format that defines how ONNX models are structured. Every new IR version expands what kinds of data types and operations a model can actually express. Over the past year, we shipped 3 new IR versions. The main theme running through all of them is support for lower and lower bit width data types. These are becoming essential for running models efficiently on modern hardware. You can see the specifics on the slide. On the right side, we also did some broader work on the type system. For example, we added a new bitcast operator, and we now support graph-typed attributes in functions. Let me talk about a change that makes life much easier for everyone who embeds ONNX in a larger system. We replaced PyBind 11 with NanoBind. This enables Python stable API wheels, also called API 3 wheels. The result is that one compiled binary works across Python 3.12, 3.13, and 3.14, and future versions too. We no longer need to build a separate wheel for each Python version. This dramatically reduces our release build metrics. We also added an automated compliance check in our CI pipeline to verify that every wheel actually matches AB3 standard. On the C++ side, we made it explicit which functions are part of the public interface. This means that frameworks like PyTorch that embed ONNX directly can now link against it reliably, resolving long-standing issues that some downstream users had been experiencing. We also cleaned up the Python to C++ binding layer to make that boundary cleaner and easier to maintain going forward. We also improved shape inference. We added 2 new API methods for unifying input shapes, which provide a proper first-class interface for output shape inference. Previously, this logic was duplicated in an ad hoc way across many operators implementations. We also added algebraic dimension arithmetic in C++. So you can now add and subtract dimension expressions directly in code. This makes symbolic shape propagation across composite operators much more tractable. On the specification side, we clarified the semantics of several operators, included integer division and several signal processing and geometry operators. We also relaxed the model domain validation from a strict requirement to a recommendation, which reduces unnecessary rejections of real-world models. And for new targets, we now publish priority wheels, which means Onyx can run direct in the browser via WebAssembly. We also support Python 3.13 and 3.14 free-threaded builds on all platforms. I'm particularly proud of what we have achieved in security and build infrastructure. On the security side, we achieved the OpenSSF Silver Badge. We set up the build level 2 provenance attestations, so every release artifact now has a cryptographic attestation of how it was built. We added a linting tool for our GitHub action workflows to catch injection vulnerabilities and overprivilege. And we implemented PEP 770, a standardized SBOM that is statically compiled into every Python wheel we publish. It records exactly which C++ dependencies are bundled inside with the license, exact versions, and hashes. We also set up continuous fuzzing, an automatic technique that feeds unexpected and random inputs to our code to uncover crashes, edge cases before they reach users. On the build quality side, we modernized our build system using scikit build core and CI build wheel. For C++ code quality, we introduced the C-lang tidy CI job and added OpenSSF compiler hardening flags. We also made Windows a first-class build target by treating Microsoft Visual C++ warnings as errors. Let me give you a quick look at what's coming next. In the near term, we have three priorities. First, we'll remove test files from release packages to reduce initial surface. Second, we are expanding our fuzzing coverage. And third, we are migrating to C++ 20, giving us access to modern language features across the entire codebase. Looking further ahead, in early 2027, we plan to publish a dedicated build SBOM alongside each release. This will document the compiler, build tools, and all Python and C++ dependency versions used to produce our artifacts, and it feeds directly into our next major goal. We are targeting Salsa build level 3. That means builds that are fully self-contained and reproducible, so anyone can verify exactly how an artifact was produced. Alongside that, we are working towards our OpenSSF Gold badge, building on the Silver badge we already hold. And the initiative I'm personally most excited about, significantly improved conformance test suite. We want to make it more flexible and easier to use, including for non-Python runtimes, so that any runtime implementing ONX can verify its conformance with minimal friction. To summarize, over the past year, the SIG shifted from reactive maintenance to proactive supply chain security and architectural modernization. The stable API, the razor type system, and the improved shape inference APIs all work together to make ONNX easier to embed, extend, and evolve without breaking downstream consumers. And I want to close with an invitation. If you have ideas, if you have needs, or if you are simply curious about what we are doing, please reach out to me directly. We hold a monthly SIG meeting and everyone is welcome to join. The more diverse the voices, the better the decisions we make together. Thank you very much. I'm happy to take any questions.